Okay, this is what we want to do. We want to open QUCS. Should be an icon on your desktop. We are going to create a new project. This week we're doing an AC project. So let's do something creative like AC Project 1. Now I have created it. And I want to go to schematics and components. I want to use a resistor, a capacitor, and an inductor in this circuit. As is true with simulation, generally you have to have ground. And I am selecting all these based on the fact that they're right here in front. Now I need to look for an alternating current source. And I get down here, I see a current probe. We'll do a current probe. I've got it clicked and dragged, and if I rotate it, or I put it here, I've got the arrow pointing an opposite way than what I want. So I go up here to the top, and I can mirror about the y-axis. Click on the part, and you see that my arrow has changed the other way. One thing to keep in mind is now that I've got this selected, I'll mirror any part icon. So to get out of that, I have to hit the escape key or go up here to the top and press this arrow where it says select. So I turned around my current probe. I'm going to probe across each of my components. It's a series circuit, PR1, PR2, PR3, and I still haven't got my AC source. And I don't see one in the lumped components. So I'm going to do my pull down menu, go to sources, and I want an AC voltage source. And it's right there. So I'm going to put it close to my ground. I'm going to ground one side of it. And I think that's all I need. Okay. Now I'm going to connect the dots, if you will. Selected the circuit line. Now all I got to do is connect dots. In a circuit class, we would be coming up with specific values of these parts based on what we want to build in terms of this. For the purposes of this EGR class, what we want to do is we just want to get you familiar with the software, get you familiar with the drag and the drop. Well, I like to make things a little bit neat. Get you familiar with the drag and the drop of putting in parts. Get you used to what a circuit looks like. A little bit. I mean, it won't be perfect, but a little bit. And man, I'm just not good at this. Make it as neat as you want. It does not have to look like this. In fact, not really that acceptable. But we've got it. We'll go in there and change some values. So I'm going to escape because I'm seeing all lines. I want to get back to the arrow. I hit the escape key. Now let's change some resistance values. So I can either double click on the resistor. I get a box that lets me edit. And instead of 50 ohms, we want to do 1 k ohm. We'll do that. Nice thing about simulation software is you don't burn up parts. That's actually not a good thing, but I'm going to go in here to my capacitor and we're going to say, ooh, I don't want a 1 picofarad, I want a 4 47 microfarad. It recognizes the U as micro. So click OK. For my inductor, I probably want something on the order of 1 millihenry instead of a nanohenry. Okay. So PR2, PR3, and PR4 are voltage sources. I believe I can name these. So voltage across the resistor. I can name this one voltage across the capacitor. Highlight it and type voltage capacitor. And I can voltage. Got to enter. Voltage inductor, enter. And then voltage capacitor, enter. And it will take it. I want a little more voltage than 1 volt. And I want to see what I have in here. First of all, my frequency is 1 gigahertz. Normally, you're going to be dealing with frequencies. 60 is a very common one. 60 hertz is a very common one. But certainly probably less than 10 kHz is going to be a frequency range that you would work in. So I'm going to go in here, I'm going to change my value. We got to have at least 10 volts. And we got to have you got to hit the enter key. 10, enter. See, it jumps down for you if you do that. And we got to do at least 100. Not gigahertz. We're going to get rid of the G. And I'm going to hit enter. Phase is phase shift theta. Not 100% sure. Oh, it's the damping factor. In transient simulation only, so you would leave it pretty close to 0. Phase is the initial phase in degrees. Normally with voltage sources, your source voltage has a phase angle of 0. So, and everything plays off the source voltage. That's just a little detail. It's not that important for you to remember, so don't stress out about it. Just go with the flow at this point. Okay, now we want to simulate this. So we know we got 100 hertz frequency. So what we have to do is we have to figure out a sampling that will show us something worthwhile. So I'm going to minimize QUCS for the time being. And I'm going to find Scilab. And I'm going to open it because Scilab is my calculator of choice. I could do it in OpenOffice as well. And we wait, and we wait, and we wait. I did click on it, didn't I? Oh, now I got hourglass. I think it opened too. I love computers. Oh no. I'll do that. Oh well. And as it Scilab twice, there goes. How do I know I have 2 instances of Scilab? Because it tells me I have 2 instances of Scilab. So I'm going to go up here and close one of them. There we go. Got the X highlighted. It'll make your computer run much better. Now I'm down to 1 copy of Scilab. And as soon as it finishes loading, I will have a cursor here where I can type in my first equation. Which is sort of what we're after. I love the fact that it shows command history, so anything I've ever done on this computer is there. I can get to it. And then it's got some other stuff that it's looking at. Anyway, I'm looking for this cursor. When you do an AC simulation, I typically use transient, because if you do an AC simulation, it lets you vary the frequency, so it gives you more of a frequency response than typically how's it act at one frequency. If you want to know how it's going to act at one frequency, I use a transient. And since I know I have a 100 hertz AC waveform, I'm going to turn that frequency into time. The period is 1 divided by 100. You can do this in your head. 1/100th is 0.01, but for those of you who feel like you got to have a calculator, here you go. Okay, so I've got 100th. In order to get an accurate representation on my waveform from a transient analysis, I need to sample each period, and I just calculated the period a minimum of 10 times. So I can take this number and I can divide it by 10, or I can realize that I just need to shift my decimal place one position to the left. So if I take my answer and I divide by 10, I will get 0.001, which is the same as shifting my my unit to the left, my decimal place to the left. I need this number because when I go to simulate it, I'm going to set up to look at possibly 20 of these. So if I want 20 points on my graph, which would be 2 full cycles of the sine wave, if I want 3 full cycles, it would be 30 points, etc., etc. So if I take my answer now and I multiply it by 40, then I know that I want to start my time at 0 and my time go to 0.04, with my time step being 0.001. That might not make sense at the moment, but let's go back into QUCS and then we'll see if we can make it go here. So bringing up QUCS, we got to do simulations. Transient simulation. AC varies frequency. Transient allows you to do one frequency. So I'm going to do a transient simulation. And the nice thing is, in beginning classes, we typically stay with the basics. What it's telling me is it's sweeping through time. It's doing a linear. It's starting at time equals 0. It's stopping at time equals 1 millisecond. Well, in Scilab, we just did a calculation that says we want to stop at 0.04. So if you want to make that milliseconds, you would change your decimal place 3 places to the right, and it would be, you want to go to 40 milliseconds with a step of 0.001. So that's why I did that calculation. So my start is that, my stop would be 40 milliseconds. My step would be 0.001. So it's going to tell me I have 41, I'll have 41 samples in my simulation, because what it's doing is it's simulating at a point in time, but if you do enough of them, you see the sine wave. Okay, so I'm going to click OK, and that should be good. I can look at the voltage across that. I should be able to look at the current. I can change this to I didn't want to cut copy, I want to change it to I of the circuit, or I total maybe. There we go. Makes it a little easier to pick out. I could put the nodes in there and name nodes and then pick them out by name. So I want to do that. Now let's try and simulate this. First thing it's going to tell me is I've got to save the project. So AC project 1, or whatever you want to name it. Click save. Now to simulate. It was successful because I've got my .dpl page open, but I don't have anything. So, haven't done one of these before. Let's see what we get if I do Cartesian. Let's see what we get here. We want to do a graph, so we want to look at voltage across of the source, voltage across the capacitor, voltage across the inductor, voltage across the resistor. I could change the order if I want to, because I think I have the resistor first. And let's do an OK and see what we get. Okay, I'm wanting to do another graph, another block. So I'm going to escape out. Now, the way we did the calculation, we should have 4 complete cycles of waveform. And we actually do. So I've got my time, my V1, my VC, my VL, and my... And I don't see the other one. They might be riding on top of each other. Voltage across resistor, voltage across capacitor. You see the characteristic, they're out of phase. This one peaks at this time. The voltage across the capacitor peaks at that time. The inductance does not show. It should be 11 volts, 10 volts, peak to peak. Let's see what we can do here. We want to see what V1 and VL so small it's not changing. It's right there on the axis, but I don't see VL or V1 anywhere. So what if I just get rid of everything but the V1? Go in, delete my graph, or delete the trace. Tell it to hit apply. Cancel. Aha! My voltage across my source is so low, it's plus and minus almost 0.1. So that's why it was not showing up. And I just picked different values in order to show how to work the software. This is not necessarily something specific in the circuit that we're wanting to work out. If you have a specific circuit, this should help you get to the point where you can analyze it, at least for 4 cycles. So, V1, VC, VL, VT. V1 is the current, because there's an I there. So if we wanted the V1 voltage, we would have to do what? Cancel that. Go back into my project. If I want to know the voltage across this, what do I have to do? I can do one of it 2 ways. I can name a node. So V source. Click OK. I now have a node there. I'm going to save it. Resimulate it. In here, my current is not worth talking about, so I'm going to delete that one. And I'm going to look at my V source, my VR, and my VC. My VL was pretty small, so let's see what we get here. Okay, that looks more like it. My V source and my V drop across my resistor are in phase, as you can see, and they're supposed to be. The voltage drop across my capacitor, however, is out of phase. If I want to make my capacitor bigger, my resistor smaller, make them more even, I could do that. But I have now got it simulated. The important thing when you go to simulate is this thing we did in Scilab, where we took our frequency we wanted to use, we divided that into 1, and then we wanted to sample it at least 10 times because this represents the period of the waveform. We wanted to sample it at least 10 times per period. You can always do more. If you get less than 5, you're going to have some issues, and if you get down to less than 2, it won't even look like anything. So 10 or more is 10 sort of your minimum for sampling. And then we wanted 4 cycles, so we knew we had to have 40 of them. So there we go. So that's what we did to set up the simulation. You got to do this for every AC circuit. If I go in and change the frequency and I go higher, I need to go in and recalculate. If I go lower in frequency, then what's happening is my waveform's spreading out, and I will by default automatically have more than 10 samples. So we're okay there. Okay, I'm going to close Scilab. And I'm going to go back to project schematic. And I'm going to make sure it's saved. And, oh, I want you to send this to me. So I'm going to do a save as. If I do a save as, I can pull down this little menu tree and I'll be able to find it on my computer. Local disk C, document settings, my name, there's a .QUCS folder, AC project folder. That is where this schematic got saved. For your deliverable for this worksheet or this assignment, I want this file. It needs to have your name on it, some kind of designation with your name on it, and I need you to submit it through Blackboard to me. Okay? So, can't remember how to get there, can you? File, save as, drop down. So when you go to attach it in Blackboard, you've got to go through that list to find it. Okay? Hopefully the sound's better this time. Worked on that a little bit. And bring this up. Do about 23 minutes.